Welcome to UBG Bytes, where we crack open the messy, confusing, and often shocking corners of the digital world. Today, we're plunging into something that recently hit the privacy landscape like a damn meteor. You might think your incognito mode or clearing cookies keeps you safe, right? Well, think again. We've got some seriously wild stuff to unravel.
Indeed. We're looking at a recent disclosure that uncovered a truly novel and concerning tracking method employed by two massive tech players, Meta and Yandex. And this affected billions of Android users globally. It's an essential look at just how sophisticated and, frankly, how surreptitious digital tracking can become, especially when companies are determined to connect every single dot of your online life.
Yeah, exactly. This wasn't some tiny, obscure loophole either. The researchers who dug into this actually called it a local mess, and honestly, that description kind of hits home. Our mission today is to unpack exactly how these companies were linking your general web browsing habits directly to your native app identities, your Facebook, your Instagram, or maybe your Yandex accounts, all without you having the faintest clue. It's a profound shift in what we thought we understood about digital privacy, and the ingenuity or maybe the audacity of it is truly astonishing.
It really is.
Okay, let's really get into the weeds of this. We're talking about covert web-to-app tracking via Localhost on Android.
Ooh, that probably sounds like a mouthful of tech jargon, right?
It does.
But the core idea is surprisingly straightforward and honestly a bit chilling when you break it down. At its most basic, certain native Android apps were like silently listening for information on fixed local ports right there on your device. Yeah, and what's truly fascinating here, and frankly quite alarming, is the abuse of what's called a localhost socket. So imagine your phone or tablet has this internal communication channel, almost like a private hotline. That lets different parts of the device talk to itself.
Okay.
This channel is called the loopback interface, addressed by 127.0.0.0.1. Now, the Android operating system generally allows any installed app with basic internet permission to open a listening socket on this internal interface. What these brilliant researchers uncovered was that web browsers on the same device could also access this internal interface. And critically, JavaScript code embedded on websites you visited could then initiate communication directly with those native Android apps listening on these sort of private channels.
Okay, wait, so if I'm getting this right, you're saying a website I visit just running in my mobile browser could actually talk directly to an app on my phone without me ever knowing or giving permission. Like a random website I click on in Chrome could whisper secrets, or rather my identifiers, to my Facebook or Instagram app in the background.
Nice.
That's genuinely wild. It's like the apps on my phone and the websites I browse were supposed to be in separate rooms, but there was this secret tunnel connecting them.
Exactly. That secret tunnel allowed them to share identifiers and browsing habits. And this is crucial because it bridged what we call ephemeral web IDs. Things like a short-lived cookie from a single website visit.
Right, the temporary stuff.
To the long-lived mobile app IDs directly associated with your actual persistent user identity. This effectively de-anonymized users. It transformed temporary, supposedly isolated web activities into permanently linked data streams associated with their social media or service accounts.
Wow.
It completely redefined what private browsing was even supposed to mean.
That's just a fundamental violation of trust right there. So tell us how Meta specifically pulled this off. What was their intricate method?
Okay, so Meta's approach was quite sophisticated. The Meta or Facebook Pixel JavaScript, which is widely used for tracking website visitors.
Yeah, it's everywhere.
When loaded in an Android mobile web browser, it transmitted the first-party FBP cookie. Now, this FBP cookie is normally specific to the website you're visiting, right? It's designed to stay put.
Supposed to, yeah.
But Meta found a way to move it. They used WebRTC. It's a technology primarily designed for real-time communication like video calls or maybe screen sharing.
Right, WebRTC.
Within WebRTC, they manipulated specific protocols like STO and later Turn. These usually help devices establish a direct connection. But they use them to send data directly to specific UDP ports. Think of UDP ports as like specific digital doorways or channels on your device.
Okay, like dedicated lines.
Exactly. Specifically, they targeted UDP ports 12580 through 12585. And what they found was that Meta apps like Facebook and Instagram, certain versions like Facebook 515 and Instagram 382 were mentioned, were found listening on these exact ports. Now, the truly ingenious and, well, insidious part was how they transferred the FBP cookie. They literally inserted its content into a WebRTC setup field called SDP ICU frag. This technique is known as SDP munging.
SDP munging. Sounds shady.
It is. It's like twisting a standard piece of communication data to secretly smuggle in something else entirely, in this case, your private cookie, makes it incredibly hard to detect.
Wow.
So once the native Facebook or Instagram app received this FBP cookie via this covert channel, it would then transmit it as something called a GraphQL mutation to graph.facebook.com/GraphQL. A GraphQL mutation is basically a command sent to a server telling it to, create or update data.
Got it.
In this case, it was telling Meta servers, hey, link this newly received FBP cookie from your web browsing session with all the other persistent user identifiers we already have for this person's Facebook or Instagram account.
So connecting the dots.
Directly. Linking your web visits straight to your long-standing social media identity. It utterly bypassed the whole idea that an FBP cookie is supposed to be first-party and contained to just one website.
So Meta's strategy basically turned what seemed like an isolated web visit into a direct data pipeline to your Facebook or Instagram identity. It's almost like they just decided the rules of the internet didn't apply to them.
Pretty much sums it up.
And Yandex, did they have their own clever, albeit creepy method for doing this kind of thing?
Oh, they absolutely did. The Yandex Metrica script, another popular web analytics tool.
Right.
It initiated HTTP requests with these long, sort of opaque parameters directly to localhost. But he used specific TCP ports, 2909, 29010, 38102, and 38103. And again, certain Yandex apps, including things like Yandex Maps, Navigator, Browser, Search, even their Metro app in Vienna and Yandex Go, were actively listening on these precise ports.
Okay, similar setup, different ports.
Similar, but with a twist. To add another layer of obfuscation, they even had YandexMetrica.com resolving to 127.0.1.
So it looked like internal traffic.
Exactly. Routing requests internally to your own device rather than out to the internet, making it look like legitimate communication happening just within your phone. But unlike Meta's direct approach, the Yandex native app acted more like a proxy.
A proxy, how so?
It received the request from the web browser, okay? And then it responded back to the browser with a base 64 encoded payload. That's just data encoded into a text string, easy to transmit.
Right.
And this payload embedded your Android advertising ID, the AID, that unique identifier for your device, often used for ad targeting, plus other persistent device IDs. Then, and this is the clever part, the JavaScript running on the website you were visiting would take all this aggregated data.
So the browsing activity plus the device IDs.
Yes, your browsing activity combined with your persistent device identifiers. And the website's JavaScript would upload all of that directly to Yandex Metrica servers.
Whoa. So the website itself was kind of complicit in sending your linked data back to Yandex.
In a way, yes. The script running on the site orchestrated the final upload.
So while the technical choreography differed between Meta and Yandex, the end result was pretty much the same. Your ephemeral web activity became permanently tied to your known identity, and it circumvented basically every expected privacy control. What does this all mean for you, the listener, in practical terms?
It means this method completely bypassed typical privacy protections we rely on.
Like clearing your cookies.
Useless in this context.
Using incognito mode or private browsing.
Nope, totally ineffective. Didn't matter.
Even Android's own granular permission controls, the ones supposed to give you power over your data.
Completely ignored, bypassed.
It's just a shocking level of covert de-anonymization. It essentially made your attempts at digital privacy meaningless in this scenario.
Absolutely.
Okay, given this absolute disregard for user privacy, what was the scale of this problem? We know Meta and Yandex are huge, but was it just a handful of sites using this, or was this tracking method really widespread?
The scale here is quite significant. Truly massive, actually. Let's look at the numbers. According to Built With, that platform that tracks web tech adoption, Metapixel is embedded on over 5.8 million websites globally.
5.8 million. Wow.
And Yandex Metrica is on close to 3 million. Another public data set, HTTP Archive, which crawls millions of sites regularly, also shows Metapixel on 2.4 million sites and Yandex Metrica on over 500,000. So huge reach potential.
That's an insane number of websites, just staggering. But were all of them actively engaged in this localhost tracking nonsense, or was it maybe just a subset of these installations?
That's the critical distinction, yeah.
Yeah.
And it's where the researchers' findings really become eye-opening, especially when you look at user consent, or the lack thereof. They performed targeted crawls on the top 100,000 websites specifically to detect this localhost communication. For Metapixel, they observed this ID sharing happening on over 17,000 U.S. sites and 15,000 European sites within that top 100K sample.
Okay, still a lot.
But here's the alarming part. A staggering 75 to 78% of those sites.
So one's doing the tracking.
Yes. They were actively attempting to perform localhost communications by default as soon as the user loaded the page.
By default,
Huh?
so automatically.
Automatically, potentially without any user consent whatsoever, before you could even click accept on a cookie banner, maybe?
That's grim.
And for Yandex Metrica, the numbers were also substantial. Over 1,300 U.S. sites and 1,200 European sites in that sample were doing this. And even worse than Meta, for Yandex, 83 to 84% of those sites were also initiating this tracking without user consent.
83%.
83 to 84%, meaning the tracking was starting even before a cookie consent form could be interacted with, or, in many cases, even if no consent form existed on the website at all.
Yeah.
It was completely under the radar from a user perspective.
So it wasn't just happening, it was happening without asking. It's just profoundly unsettling, grimy even.
This pervasive lack of consent makes me wonder, how long has this kind of under-the-radar tracking been going on? Was this a recent invention or more like an evolving strategy? Yeah, it wasn't a sudden discovery. These techniques clearly evolved over time. It indicates a continuous effort by these companies to adapt and find ways around privacy measures. Yandex, for instance, seems to have been refining its approach since way back in February 2017. That's when their HTTP method was first observed.
2017, wow.
Yeah, and they updated it to use HTTPS in May 2018. Meta's methods were more recent, starting with HTTP in September 2024. Then they introduced WebSocket in November 2024, and then WebRTC Stirdown, also in November 2024. They'd even rolled out a new WebRTC turn method in May 2025.
So constantly changing tactics.
Exactly. It's been an ongoing, escalating cat-and-mouse game with these companies constantly trying new tactics to connect user data across different platforms.
Okay, so we've established this tracking was widespread, utterly non-consensual, and completely bypassed nearly every existing privacy protection we thought we had. But here's where it gets really interesting and maybe even terrifying. Beyond just the privacy invasion itself,
Right.
the added risk of browsing history leaks.
This raises a truly critical and concerning question, doesn't it?
Yeah.
What if a malicious app was also quietly listening on those same ports Meta and Yandex were using? And the researchers didn't just theorize this. They actually demonstrated it with a proof of concept app.
They built an app to test it.
They did.
Yeah.
Because Yandex and earlier versions of the Meta method use standard HTTP requests for their web-to-native ID sharing.
Yeah.
Any other app installed on your device, if it were built maliciously, could simply listen on those specific ports, 2909, 29010, etc.
Okay.
If it did, it could intercept those requests and passively monitor every single website a user visited just by looking at the origin HTTP header. That header essentially reveals the website address.
Hold on. So if I downloaded some seemingly innocuous app, I don't know, a random flashlight app, a QR code scanner, whatever,
Right.
and if it was built with malicious intent, it could secretly be reading every single website I visit on my phone, even if I'm using incognito mode in my browser thinking I'm invisible.
Yes.
That's not just wild, that's a complete nightmare scenario for personal security.
That's precisely what their research proved. They showed that popular browsers like Chrome, Firefox, and Edge were all susceptible to this specific form of browsing history leakage. And importantly, in both default and private browsing modes.
Both modes. Wow. It was a significant vulnerability. Now, some browsers did fare better. Brave browser, for instance, was completely unaffected.
Why Brave?
Because it has a strong built-in block list, and crucially, it has a policy since 2022 of requiring explicit user consent for any localhost communications.
Okay.
Proactive.
Very. DuckDuckGo was only minimally affected because it was missing just a few specific Yandex domains in its block list, which they patched very quickly once this research came out.
Good on them.
Yeah. Now, while the researchers didn't actually observe other non-Meta or Yandex apps exploiting this in the wild, the technical capability for them to do so absolutely existed. It really highlighted a critical security flaw in how the Android operating system allows apps to communicate internally, or perhaps doesn't restrict it enough.
And the really bitter pill to swallow here, you, the end user, were completely in the dark about all this. This method worked its magic even if you weren't logged into Facebook, Instagram, or any Yandex service on your mobile browser.
Correct. Didn't matter.
It worked if you actively chose to use incognito mode.
Yep.
It worked if you meticulously cleared all your cookies or browsing data.
Still worked.
This tracking technique wasn't just a workaround, it completely defeated Android's inter-process isolation, that system designed to keep apps walled off from each other to prevent exactly this kind of data sharing.
Right, the sandbox principle.
And it bypassed other tracking protections. It's like your digital fortress had this secret, completely unknown backdoor that no one ever told you about.
That's a very good analogy for it.
So, considering the gravity of this discovery, widespread, covert, privacy busting, and a major security risk, what happened after these researchers blew the lid off this local mess? Did Meta and Yandex fess up? Did browser developers scramble to fix it, or did they kind of drag their feet?
Well, the researchers followed a responsible disclosure process, which is the ethical standard in cybersecurity. They worked privately with major Android browser vendors before making their findings public.
Good.
And credit where it's due, the browser community reacted fairly quickly and decisively for the most part. Chrome, for instance, in version 137, released on May 26, 2025, shipped specific countermeasures. These included blocking these abused local host ports and disabling the specific SDP munging technique that Metapixel had been using.
So they addressed both the ports and the method.
Yes, and these defenses are already being trialed for a subset of Chrome users, meaning a fix is actively rolling out.
Okay, that's progress. What about others?
Firefox version 138 was still affected by the Yandex method, but interestingly, not affected by the Facebook method.
Wonder why.
Not entirely clear from the report, but version 139 is slated to include countermeasures to block the involved ports for Yandex as well. DuckDuckGo, as we mentioned, was only minimally affected and very quickly amended its block list.
Quick response.
And Brave, commendably, was not affected at all, thanks to its existing strong privacy features.
Right, the localhost consent thing?
Exactly. Since 2022, Microsoft Edge was also affected, but their specific mitigation plans weren't detailed in the research report itself. So from the browser side, overall, a strong, fairly swift response.
Okay, so some definite good news from the browser developers who actually seem to prioritize user privacy, or at least reacted quickly to a clear threat. But what about Meta and Yandex themselves? Did they issue public statements? Did they come clean about these practices, offer some kind of explanation or apology to the, billions of Android users affected?
This is where it gets particularly interesting and frankly a bit mysterious and, well, frustrating. As of June 3, 2025, which was just after this research disclosure, the Meta Facebook Pixel script is no longer sending any packets or requests to localhost.
Wait, really? It just stopped?
Just stopped. The very code responsible for sending that FPP cookie via these covert channels. It's been almost completely removed from the Pixel script. And Yandex has also quietly stopped the practice described in the report.
Stopped. Cold turkey. No explanation. No public statement. No, hey, we were doing this shady shit, but we've stopped now. Our bad.
No. Nothing like that.
Okay.
The researchers explicitly state they don't know why these companies stopped. But they're certainly pleased that Android users are no longer affected by this specific method, at least for now.
For now is the key phrase there.
Exactly. And crucially, they found absolutely no public documentation from Meta or Yandex ever describing this method. What's even more telling is that website owners and developers were actually complaining in Facebook developer forums as early as September 2024.
Complaining about what?
About seeing the Pixel script communicating with localhost on their users' devices. They were puzzled, asking what was going on, and they apparently received generic responses, or more often, just no official responses at all. As one frustrated developer noted back then, quote, "No acknowledgement has come from Meta at all on this, though."
Wow. So they knew people were noticing, or at least asking questions, and they just ignored it.
It seems that way. It's like they were caught with their hand in the cookie jar and just quietly withdrew it without saying a word when the research became public.
That's pretty wild and honestly a bit infuriating. It truly underscores why transparency from these massive tech companies is not just a nice to have, it's absolutely crucial. If they're doing things like this without documentation, without telling anyone, how much else is happening under the hood that we just don't know about?
Absolutely. It raises serious questions about accountability. And while this research specifically targeted Android, the researchers do note that similar types of covert data sharing on iOS devices are technically possible. Although, to be clear, they found no empirical evidence of it being actively abused there. But the potential exists. The fundamental issue remains apps having this kind of unvetted access to localhost sockets.
Yeah.
It poses a broader concern about how different components of our devices communicate behind the scenes and what safeguards are truly in place.
So what's the ultimate takeaway from this whole local mess, this pretty deep dive into covert tracking? You might have walked away from this thinking you're fully in control of your privacy by clearing cookies, using incognito, fiddling with app permissions. We try, right?
We do.
But this case proves how incredibly sophisticated and, well, covert tracking can get. It's not just a constant battle, it's a profound shift in understanding how your digital life is being interconnected without your consent, sometimes without even your knowledge.
Indeed. This research really underscores that user-facing controls, while important, are often insufficient on their own. We need stronger platform policies from Google, in this case, and enhanced security around inter-process communication, basically, how different software processes talk to each other on the device. We, as users and researchers, have to be vigilant and continue to demand more genuine transparency from these companies about exactly what data they're collecting, how it's being linked, and for what purpose. Because if these hidden channels exist, the incentive to exploit them for valuable user data is always going to be there.
Seriously, this isn't just about showing you more targeted ads, is it? It's about your entire digital identity being stitched together across platforms in ways you never agreed to, maybe never even imagined. For you, the listener, it's a stark reminder that digital privacy is a constantly moving target. It's a complex arms race. And staying informed, understanding these kinds of mechanisms is truly your best defense. Makes you wonder, what other hidden connections do you think might be out there right now, quietly linking the disparate parts of your digital life? It's a chilling thought.
It really is. Thanks for tuning in to UBG Bytes. We'll catch you on the next exploration into the digital unknown. Stay curious, stay skeptical, and keep asking the hard questions.